Chapter 8.7 is factoring special cases. So there are two special cases. One is called the perfect square trinomial, and that factors to two binomials that are exactly the same. And the second one is the difference of squares, which factors to two binomials that are conjugates. Basically, this chapter is the opposite of chapter 8.4, which is multiplying special cases. So let's take a quick look at this. Should be a one video look. So when we're factoring and you see a perfect square here in the C position and a perfect square here in the A position or AX squared position, always give this a try. X, X. I'm going to use two pluses because I have a plus in the middle. And I'm going to take the square root of 9. So 3. Now, you can see the middle term is going to be 3x and 3x. The outer and the inner are going to be 3x and 3x. That's the 6x. This should be an x, by the way. So therefore, this equals x plus 3 squared. It is a perfect square written as a trinomial. That should be an x. The next one. Again, we see a perfect square. And we see another perfect square. This one has a variable on it. So here, we're going to try to have the variable. The square root of 25, x squared is 5x. The square root of 49, y squared is 7y. And here we have a minus sign. Now, the middle term, this is going to be 5 times 7, that's 35. We're going to do the same thing again on the outers. That's going to be the 70, and it's going to be xy. 5 times 7 xy is going to be 35xy, but there's two of them, so there's negative 70xy. So this equals 5x minus 7y squared. Okay, so those are perfect square trinomials. When you see a perfect square here and a perfect square here, you do have to check the middle. Notice what happens is that if you take the 5x and the 7y and multiply them together, and then multiply them by 2, because you have an O and an I, that's what gives you that middle term. So this needs to be 2 times the square root of the first term times the last term. And if it is, you have a perfect square trinomial. Go over that carefully, make sure you realize what's going on there, because if this term isn't the right term, you don't have a perfect square trinomial. It has to all fit together. All right. Now, difference of squares. When you have a two-term, a binomial quadratic with no middle term, no x, just an x squared and then a constant, and you have a minus sign. This has to be a minus sign. We talked about this when we were doing this the opposite direction. We were multiplying. That has to be a minus sign. This will become conjugates. So take the square root of the first term, take the square root of the last term, and put your plus and minus in. Now your plus and minus means there's no middle term. The last term, negative, positive, 13 is negative 69. The first term is x times x squared. Same thing here. Oh, wait a second. That's not a perfect square. Nor is that. Oh, but there is a greatest common factor. So let's get rid of this. Equals 2 times 25 x squared minus 49 y squared. Okay, so we can't lose track of that 2. So we have a 2 times, we're going to have a conjugate here with, because we now have perfect squares. 5x, square root of this is 7y. We need a plus and a minus so that the middle term goes away, and this will multiply back to that. That is all for this chapter, just one quick video. I hope it didn't take too long. And so chapter 8.7 is done. Hope you enjoyed that.